Hi, everyone. Today we're going to be talking about the mean value theorem. So, the mean value theorem is going to be you're going to really understand it by looking at this diagram, but let's look through the words. So, it says the picture below shows a function f that is differentiable on AB with a secant line passing through these points. Okay, so right here, this right here is the secant line. Okay, remember secant cuts through in two places. The slope is the average rate of change, so slope is slope, you know that, over AB, that domain. The mean value theorem says that there's a point somewhere within the domain AB where the slope of the tangent line is parallel to the slope of the secant line. So there's this point where the tangent line will be parallel to the secant line. So here's what we have to do. It's a little bit similar to Rolle's theorem, but that was looking for the slope to be 0. Okay, so let's take a look. Let's move this up and let's do an example. This is just showing the slope at the point. Okay, see. So here's what we're going to do. We're going to look at this example, and what it says is we have to determine whether the mean value theorem applies. So we're going to kind of have the checklist like we did before. So is it continuous? Yes. Okay, it's a parabola. Is it, oops, I meant to change this to a 3. Okay. Is it differentiable on this domain right here? Yes, it's a parabola. So it doesn't have a cusp or a corner or a break in the graph, as we already talked about. So yes, it's continuous. So what we're going to do is we're going to find f of -2. Okay, because we're going to find this height and this height right here. So f of -2 is 3. And then we're going to find f of 3. And if you put a 3 in here, we get 9 times 2 is 18 minus 5, and we get 13. So we have a point on this graph at -2, 3. We have a point on this graph at 3, 13. What we'll now do is find the slope between those points, which is the average rate of change. So I set it up like this, and then I drop my numbers in. So -2 under 3. You might do it a little different, but our numbers should land in the same spot. And then 3 under 13. What we get from that is -10 over -5, which cleans up to be a slope of 2. All right, so let's look at this. Let's think about this. We're going to graph over here our parabola. And you better remember that this parabola goes down 5 units, right? And then it goes up times 2. So over 1, up 2, over 1, up 6. And we're just estimating, but I just wanted to at least have something to look at here. So let's connect this. You'll be able to use your calculators for a lot of these. But what this shows us is we have the point -2, 3, and we have the point 3, 13. I didn't even get to that, but 3, 13 would be like up here somewhere. Okay, so that is the line that connects those 2 points, -2, 3 and 3, 13. What we're saying with the mean value theorem is that somewhere along this curve, there is a line that has the same slope, that has a slope of 2. Well, we know how to get our tangent line, right? We take the derivative of the function. So the derivative of this function is just, use a power rule, 4x. And we want to know when the slope of the tangent line is 2. So now we've set it equal to 2. We divide by 4 on each side, and we find out that when x is 1/2, the slope is 2. So if you look here at x is 1/2, so it'd be somewhere right around here, right? Because this was 0 and this is 1. The slope will be 2. Whoops, and I'm not drawing it very well, but that slope would be 2, which is parallel to this slope, which is also 2. So that's really what we're looking at. Okay, so when x equals 1/2, the slope of the tangent line is parallel to the slope of the line that we started with. So let's go ahead and let's look at another example or two, and then of course you'll be on your own because you'll be able to do this. So on the next page, oops, I think that's not the page I wanted. Okay. Okay, sorry about that. I was going the wrong way. Okay, so get to this page and we're going to do the same thing that we just did. Okay, so we're going to figure out what the slope is. First of all, we do our little checks. Is it continuous? Yep. Is it differentiable along the graph or along the function from -2 to 2? Yep, because it's just a parabola. So then what we're going to do is we're going to find f of -2 and f of 2. So you can put this in your calculator if you want and pull up your table, or you can do the calculations in your brain. So f of -2 is 5. F of 2 is also 5. So we can tell with this one, it actually has a slope of 0, right? Because if the heights are both 5. So this is very much like Rolle's theorem, okay? Kind of both at the same time. What we're going to do is we're going to take the derivative of our function. So here's the derivative equals 2x. And we're going to set it equal to 0 and solve. So when x equals 0, we have a slope of 0. Okay, and let's just graph this function for a second here, just so we can kind of see what this looks like. So again, this is a parabola that has moved up 1 unit, but it's your kind of normal parent function size, right? Okay, it's going to look like that. And this line right here is the line that goes through -2, 5 and 2, 5. And that has a slope of 0. This line right here at the bottom through the vertex is the slope of the tangent line, and it also has a slope of 0. Now, do you think they're all going to be that easy? I can promise you they are not. So let's do the next one because that's going to bring into play something you haven't used in a little while. So let's look at this function. So it's x cubed plus x squared. That is a function that will not have any breaks in it. Okay, so just looking at it, kind of looks like this. And I pulled it up on my calculator to kind of plot some points, but it looks like that. So is it continuous? Yes. Is it differentiable along that domain? Yes, it certainly is. So we will find f of 0. So f of 0 is 0. And we'll find f of 1, which is 2. And again, you can put that in your calculator and pull up the table. That's probably the easiest way. So we can go ahead and calculate the slope. Okay, and we're going from 0, 0 to the point 1, 2. Probably could have done that in your head, right? -2 over -1, which is 2. And that kind of makes sense because we're going from 0, 0 to 1, 2. So we have a slope going like this. So now we want to know where is the tangent line that also has a slope of 2 that's between these numbers. I forgot to say that before. It has to be within this domain. So we're going to take the derivative of this function and set it equal to 2. So I'm going to do it right now. 2 equals 3x squared plus 2x. So in order to solve this, because it's a quadratic, of course, we set it equal to 0 and we factor. But guess what? This doesn't factor. So now we have to use, let's see, can you think about it? Quadratic formula. It's been so long. So remember, it's the opposite of b plus or minus the square root of b squared minus 4ac all divided by 2a. I'm going to run out of room for sure. When you clean up under the radical, you get 28. So it's negative 2 plus or minus the square root of 28, all divided by 6. We're going to clean up that 28. It's going to be root 4 times root 7, which gives us 2 root 7. And then we're going to simplify the 2, and the 6. So what we get is negative 1 plus or minus root 7 over 6. Now here's the deal. We have to look and see, are those numbers within the domain that we were given? So 0 to 1. So if you do negative 1 minus root 7 divided by 6, that number falls outside of the given domain. So negative 1 minus root 7 divided by 6 is negative 0.6. So that falls to the left of this, because there would be another line over here, but we're not interested in that. So if we do negative 1 plus root 7 divided by 6, we get approximately, I'm sorry, we should be dividing by 3. Oy, oy, oy. Of course, there's always a mistake, right? I forgot to do that. Should be dividing by 3. So divided by 3 gives us 0.55. So the answer is negative 1 plus root 7 over 3, which is approximately 0.55. Okay. And that would be, so if you can think about it, this is 0, this is 1, so it's somewhere right about here. You can see that that tangent line would also have a slope of 2. Okay. Why don't we go ahead and do one more? Okay, I'll try not to make any mistakes this time. Okay, so let's take a look at what we have. So we have a function, sine of x. Okay, so we know how to do this. We're going to go ahead and, take, is it continuous? Yeah, because the sine curve is continuous from 0 to pi over 2, of course. And is it differentiable? Yeah, it doesn't have any cusp or corner or anything like that. So we're going to take f of 0. F of 0 is 0. And f of pi over 2 is 1. So we're going to use that to calculate the slope. So slope equals pi over 2 under 1, 0 under 0. So you can see very clearly that the slope, we have 1 divided by pi over 2, which we're going to change to 1 times 2 over pi, right? Instead of dividing by a fraction, we multiply by the reciprocal. So we actually get a slope of 2 over pi. It's okay to have that slope, right? So here's what we're going to do. We're going to take the derivative of this, and you should, sorry, I hit something. We're going to take the derivative of our function, and you should probably know that by now, which is just cosine of x. And we're going to set it equal to our slope. 2 over pi equals cosine of x. Now, I'm glad we're doing this problem because in order to do this, we're going to have to put this into our calculator and approximate. So what we can do, remember, to solve for x, we take inverse cosine of each side. So you're going to do inverse cosine in your calculator. Remember, you hit second cosine, 2 divided by pi. And what you should get is that x is approximately 0.88. So let's take a look at this. What does this look like? So if we can think about sine, let's look at our original function. Okay, it starts at 0, 0. At pi over 2, which is really the whole domain that we're looking at, it has a height of 1. And I don't know, I just feel like I have to put this here. So this is what our function would look like. Remember, then it would go down and up. We're actually only focused on this domain from here to here. So the tangent line had a slope of 2 over pi, okay, which, is about 0.63. And what this is saying is at 0.88, we would also have a slope of 2 over pi. Okay, so let's look at this. Let's see, pi divided by 2. So pi divided by 2 is 1.57. If we had to put it as a decimal, this is 1.57. So close to halfway, close to pi over 4. Okay, somewhere in here is 0.88, where the slope is the same. Okay, so you're going to go ahead and do the rest of the problems, and you're going to be just fine. Hopefully I got you a good start on this. Have a great day, everybody.